So here we're supposed to apply different techniques, and for this one you can see that we need to first start by factoring out a coefficient, right? So 6x to the fourth is not a perfect square, and 96 is not either. So first we're going to start by factoring out a 6. So what do we get? We get 6 parentheses x to the fourth, and we have minus 16. So 6 times 16 is 96. Right? So now we have perfect squares, right? X to the fourth is a perfect square, and 16 is a perfect square. So now we can apply the difference, factoring differences of squares. Right? So let's go ahead and do that. Let's figure out our a and our b. So our a squared is going to equal to x to the fourth, and our b squared is going to equal to 16. So to figure out a, we need to take the square root of both sides. So we'll do that, and we'll get a is equal to x to the 2. No, I'm sorry. A is equal to x to the 2. And then we'll take the square root of both sides to figure out what's b. So b is going to equal to 4. So now that we have a and b, we can go ahead and factor just this polynomial. And so we will get 6 times x squared plus 4 times x squared minus 4 as our answer. And then can we keep going? Yeah, I think we can keep going on this one here, right? So this one, we have a perfect square on this term, and we have a perfect square on this one. So we can get an a and a b again, and we can factor this one using the difference of squares method. So let's do that up here. We have a squared is equal to x squared, and then b squared is equal to 4. So to figure out a squared, we got to take the square root of both sides, and x squared, the square root of x squared is x. And then the square root of 4 is 2. So we have our a and b. And then we'll drop it all in, and instead of having this third polynomial factor, we will substitute the difference of squares. And let me go ahead and just put the answer down here. It's going to be 6 times x squared plus 4, as we have. And then on this polynomial, that's where we're going to substitute. So it's going to be x plus 2 times x minus 2 using the factoring differences of squares method. And this is our final answer. So let's go ahead and look at this one here. This one we need to start by grouping, because I don't see any way we can apply the techniques that we've learned so far without grouping. And so we're going to group, let's see, which one should we group? We're going to group these two guys and those two guys. So we'll get r to the 3 plus 6r squared in parentheses plus 11r plus 66 in parentheses. And then on this side, we're going to factor out, right? So what can we take out? Well, the coefficient, this one starts with a 1, so we can't factor out any of the coefficients. But we have 3 r's here, and we have 2 r's there, so we can take out 2 r's. So r squared times r plus 6. And then over here, what can we factor out? Well, we can take out an 11. So we could say r plus 6 like that. And then you can see here that this term has a factor of r plus 6, and the second term has a factor of r plus 6. So we could factor that out, and we could say r plus 6 parentheses, and then that leaves us with r squared plus 11, like so. And then you want to look at this here and say, hey, is this a perfect square? Yes, it is. Is this a perfect square? No, it's not. So we leave it as is, right? But if it did have 2 perfect squares here, and this was a minus sign, we could apply the difference of squares method. So let's go ahead and put r plus 6 and then r squared plus 11 as our second factor.